Awak yang tu lah. Jangan lupa subscribe channel kita, tanda sokongan. Terima kasih.
Assalamualaikum and hi everyone. So welcome back to my channel. Jadi dalam video kali ini kita akan teruskan dengan set yang keempat dan kita akan mulakan dengan soalan yang ke-11 dan soalan 20 11 hingga 20. Okay, so jom kita mula. Okay, so question 11. Alright, so let's read the question. So here we have two objects. So the first mass is 3 kg and this is 1 kg. So I will label this as M1 and this as M2. Okay, and these two masses are connected by a light inextensible string passing over a smooth pulley. Okay, so the system is released from rest. Okay, with the 1 kg mass on the ground. So this is 1 kg mass and 3 kg mass at a point of 2 meter above the ground. Okay, so kita boleh tulis dekat sini initially. Okay, so siapa yang akan ada potential energy? Mass yang kedua, mass yang pertama saya tulis U1 is equal to mgh, which is m1 gh. So m1 kita adalah 3 kg times 9.81 times 2 meter the height. Okay, so kita boleh kira lah berapa dekat situ. Okay, and then soalan kata apa lagi? The system is released from rest. Okay, alright. With 1 kg mass on the ground and the 3 kg mass at a point of 2 meter above the ground. So we want to calculate the change in gravitational potential energy of the system when the 3 kg mass reaches the ground. Okay, so we need to draw the final condition. Okay, so let's say here, this is the condition. Okay, where this is the mass of 3 kg, which is on the ground. Okay, this is 3 kg mass and this is 1 kg mass. Okay, at this moment, 1 kg mass is 2 meter from the ground. Okay, soalan dah bagi tahu tadi kan? Okay, bila 3 kg mass reach the ground, so means that 1 kg mass akan berada pada 2 meter height. Okay, so kita boleh kira pula, this is mass 2. We can write at this moment, gravitational potential energy for mass 2 is equal to m2gh. So m2 is 1 and 9.81, h dia adalah 2. Okay, so sekarang soalan suruh kita kira change in gravitational potential energy. Okay, so kalau kita tengok kat sini, ini lagi besar daripada sini lah. Potential energy for initial condition is bigger than potential energy at final condition. Okay, so we can write that delta U is equal to, okay, we can write M1GH tadi minus M2GH. Okay, saya tolakkan yang besar, tolak yang kecil. Okay, so kalau you substitute dalam you punya equation, okay, so kita akan dapatlah nilainya adalah berapa jawapannya? Okay, cuba you kira. So saya dapat 39.24 joule. Okay, so the answer is D. Boleh Okay, next question, question 12. So let's try. Look at this is from chapter 6, circular motion. Okay, so we have a roller coaster that loaded with passengers, alright, has a mass of 2000 kg. So the radius of curvature of the track at the bottom. So this is the position of the roller coaster, which is at the bottom of the tip, is 24 meter. So given that the radius, so let's say this is the circle. Okay, this is the roller coaster track. Okay, and then let's say you have here, okay, so this is the roller coaster and this is the center. Okay, and the radius is given. So this is the radius R, which is 24 meter. Okay, and if the vehicle has a speed of, so given that the speed V is 18 meter per second, the radius is 24 meter, and the mass of the roller coaster is 2000 kg. Alright, so what is the force exerted on the vehicle by the track? Okay, the force is exerted, okay, tengok kat sini, force is exerted on the vehicle by the track means that normal force. Okay, so let's try to draw the free body diagram. So kita mesti ada W, okay, the weight of the roller coaster sekali dengan passengers tadi, okay, and then we're going to have normal, okay, N, ataupun kita kata reaction force. Okay, reaction force tu adalah force is exerted. This is the force exerted on the roller coaster ataupun vehicle by the track. Okay, and saya selalu ingatkan awak untuk lukis kecil saja. Okay, you already know that the direction of centripetal acceleration always towards to the center of the circular path. Okay, so you can see here, okay, at this point, soalan kata kat mana tadi? At the bottom point of the tip. Okay, you can see here that the direction of the normal force is same direction as the centripetal acceleration. So bila kita tulis equation, okay, total force FC, centripetal force, is equal to MAC. Okay, and the only force that provide the centripetal force for this case adalah normal. Okay, N lah, sebab N sama direction dengan AC tadi. So N akan jadi positif, N plus, dan jangan lupa kita ada W, which is in Y component, kan? Tapi dia opposite direction dengan AC. So dia mestilah negatif W. And it is equal to, soalan dah bagi V, so saya akan tukar AC kepada V squared over R. Okay, therefore, N is equal to mv squared over R plus W. Okay, so we can write N and we can calculate N. Masukkanlah semua nilai, which is 2000, okay, times V is 18 squared over R is 24 plus, so the weight, okay, weight 2000 darab dengan gravity 9.81. Okay, so finally N you akan dapat 4.7 exponent 4 Newton. Okay, so this is the answer and the answer is B. Okay, boleh. Alright, good. Alright, so next question from chapter 7, which is question 13. Okay, so we have here figure 4. Okay, shows two objects P and Q with masses 2m and 3m. So tulislah dulu. So this is 2m and this is 3m. Okay, and they are separated by a distance of 1000 kilo, 1000 kilometer. Okay, a rocket travels from P. So here we have a rocket, okay, that travel from P to Q, and at certain point, at this point, okay, dia bagi tahu apa tu? Calculate the distance x, okay, where x is from P tadi, when the resultant gravitational force on it is 0. Resultant gravitational force on the rocket is 0. Okay, so means that we write that total, okay, total gravitational force on the rocket, R stand for the rocket, is equal to 0. Okay, so this is the information that we have. Okay, and on the rocket, kita mesti lukislah gravitational force on the rocket due to object Q. So saya akan tulis FR on the rocket due to object Q, and the direction is to the right, and gravitational force on the rocket due to object P, the direction should be to the left, FRP. Okay, FRQ is to the right, so it should be positive. So kita masukkan dalam sini, total gravitational force on the rocket should be F, positive FRQ plus negative FRP, and it is equal to 0. Okay, so based on this information, okay, let's rearrange that equation. Formula force apa dia? Kita susun dah balik. FRQ is equal to FRP. So, formula dia adalah G, mass of the rocket times mass of object Q, bahagi dengan jarak antara objek Q dan juga roket. Okay, R, okay, jarak antara RQ squared. R tu adalah roket lah. You nak buat R besar pun boleh lah. Sini So, this is the distance R from P to Q. Tapi kalau daripada roket ke Q ini, iaitu 1000 kilometer minus dengan X. Okay, so kena tahu yang ini. Ini dan ini adalah X jarak dia. Okay, boleh Okay, so yang sebelah ni pun sama juga. Okay, gravitational force between the rocket and object P, G, mass of the rocket times mass of P over the distance between P and the rocket. Squared jangan tertinggal. Okay, so apa yang you boleh cancel? You cancel G boleh potong. The mass of the rocket is not given, but we can cancel out the mass of the rocket. So here we have MQ, and it is given 3m. And the distance between the rocket and Q adalah 1000 kilometer minus X squared is equal to mass of P is 2m over the distance between the rocket and mass P is X squared. Okay, so yang ni saya akan cancel M. Okay, di sini kamu jangan expand. Jangan buka bracket, jangan expand. Maksud saya ini. Saya highlight kejap. Okay, so maksud saya ini. Okay, squared ini you jangan buka. Okay, cara yang paling mudah, you bawa semua. Okay, semua yang ada squared you move in one side, and 3 ini, 3 ini you bawa turun ke bawah. Okay, so dia akan jadi apa? Dia akan jadi X squared over 1000 exponent 3 minus X. Okay, squared is equal to 2 over 3. Okay, so sekarang saya nak buang squared ini. So, saya akan take the square root. Okay, jangan lupa take square root for both sides. So, we can cancel this one. Okay, therefore, we can write, saya tak muat saya tulis kat tepi ni. Okay, so dia akan jadi X over, okay, 1000 kilometer minus X is equal to, ini you selesaikan lah. So, ini kita akan dapat berapa tu? Sekejap Okay, jadi yang ni you boleh selesaikan. Okay, square root 2 over 3. So, you akan dapat 0.8165. So, rearrange that equation. You boleh dapat 0.8165. Okay, ni bawa ni atas. Okay, times 1000 kilo minus X. So, now we can solve for X. Therefore, X is equal to 4.49 exponent 5 meter. Okay, so this is the answer, and the answer is A. Alright, jangan tersilap Okay, the answer is A. Okay, so finish question 13. So question number 14. Alright, so let's try to read the question first. Okay, so the mass of a planet, okay, so here we have the mass of the planet is 5 times 10 power of 24 kg, and it is given, so this is the mass M, and this is the radius of the planet, and this is R. So the energy required for a body of mass 2 kg to escape completely from the planet is, so we want to calculate V escape. Okay, so we can straightly use equation V escape lah. This is very simple. Square root 2gr of the planet, ataupun you kata nak guna formula satu lagi, V escape is equal to square root 2gm over r. So dia merujuk kepada planet ni. So m ini adalah mass of the planet and r is the radius of the planet. Okay, you nak guna mana-mana pun boleh, tak ada masalah. Nak guna yang ini pun boleh. So saya akan masukkan nilai dia lah, 6.67 exponent negative 11 times the mass of the planet okay, divide the radius of the planet. Okay, so you akan dapat jawapan dia 1.1 exponent 4 joule. Okay, so the answer is C. You nak guna ini pun boleh, you akan dapat jawapan yang sama. Okay, cuba kira. Okay, so next question 15. Okay, so we have an object of mass 1 kg is connected to a helical spring which undergoes simple harmonic motion of period 1 second. So determine the new mass if the period of oscillation is to be reduced to 0.5 second. Okay, to be reduced to maksudnya dia berkurang sehingga 0.5 second. Okay, bukan reduce by, reduce to. Okay, kalau reduce by dia berkurang sebanyak. Ini reduce to maknanya daripada berapa? 1 second dia reduce to 0.5 second. Okay, itu ada dua benda yang berbeza. Okay, so sekarang, okay, kalau saya tulis kat sini lah. Kalau reduce by, kan? So berkurang sebanyak. Maknanya pengurangan dia tu adalah, dia akan jadi T initial minus 0.5 equal to berapa? Okay, tapi reduce to 0.5 means that T final dia equal to 0.5 second. So kena faham Okay, so kat sini kita cerita pasal apa? Okay, helical spring. So kita ada 1 kg mass, 0.1 kg mass. Okay, contoh you ada spring. Okay, and then you attach the mass M. Okay, so bila you letak M, dia kata the period T is equal to 1 second. Tapi bila you letak, okay, mass M prime, so letak M prime, T baru dia adalah T prime is 0.5 second. Okay, so daripada sini kita boleh tahulah. So let's say this is the original condition and this is the new condition. So saya nak buat apa? Kita buat satu-satu. Okay, so we start with the original one. Okay, where T, the period, okay, relationship antara T and M, formula dia adalah 2 pi square root M over K. Dan ini adalah spring yang sama. Spring ini dengan spring ini adalah sama. So nilai K, which is the spring constant untuk kedua-dua case original dengan yang new tadi mesti sama. Okay, so dia akan jadi apa? Okay, saya simplify this equation. Saya nak hilangkan square root dia. So this one should be 4 pi squared M over K. Boleh Okay, so saya akan tulis K is equal to 4 pi M over T squared. 4 pi squared. Okay, 4 pi squared. Okay, and then kita tulis yang sebelah ni pula. Tadi yang original. So ini yang new punya. Okay, so kalau yang new punya sama je. T prime is equal to 2 pi over, M prime over K. Kan K ni tadi sama. Saya sama juga, saya rearrange that equation. So saya akan tulis K is equal to 4 pi squared M prime over T prime squared. Okay, so now we want to calculate the new mass M. Okay, so saya ada equation number 1 and this is my second equation. So apa yang saya buat sekarang? Saya akan samakan. Ini kan K sama. So kita akan tulis equation number 1 is equal to equation number 2. Okay, equation number 1 is equal to equation number 2. So we can write 4 pi squared M over T squared equal to 4 pi squared M prime over T prime squared. Jadi apa yang kita boleh cancel adalah 4 pi squared. Okay, therefore we can find M prime is equal to M times T prime squared over T squared. Jangan lupa ya, yang prime ini yang baru, yang new. Okay, so masukkan nilai dia. So M tadi yang asal adalah 0.1 kg times T prime kita adalah 0.5 seconds, squared jangan tertinggal, over T is 1 second, so 1 squared. Therefore, the answer yang saya dapat adalah 0.025 kg. Okay, so this is the answer. Alright, and the answer is B. Okay, so ini jawapan dia. Okay, so finish question 15. And then question 16. Okay, we're still in chapter 9. So the graph shows the variation of displacement against x. Okay, sorry, displacement x against time t of a body in simple harmonic motion. Which statement is true? So bila you dapat graph, you tengok dulu. Ini graph x against t. Okay, and for one complete oscillation, dia tak bagi the period t. Okay, kita tak ada nilai t. Tapi sekarang soalan bagi kita ini 0.6. Jadi kalau situ 0.6, sini mestilah 0.5, 0.4, 0.3, 0.2, 0.1. Okay, so for one complete oscillation, okay, so sini. So here is the value of the period t, where t is now equal to 0.4 second. Okay, so daripada graf kita analyse dulu. Dan nilai yang ini pula, yang saya bulatkan kali hijau ini adalah dia punya amplitude. Okay, sebab ini adalah graf x against t. Tapi kalau soalan bagi ini adalah graf v against t, kalau ini adalah graf v against t, okay, contohlah, okay, you dapat macam ini. So nilai kat sini tak bolehlah you kata dia adalah amplitude. Nilai yang paling maksimum pada graf ini adalah v maximum, where v maximum is equal to, equation dia adalah a omega. Jadi kalau nilai kat sini dia bagi 10 meter per second, means that the value of v maximum is 10 meter per second. Okay, so sekarang kita nak pilih which statement is true. So the period is 0.3 second. Betul ke? Salah. Sebab kita dah kira tadi 0.4. Okay, so this one is salah lah. Okay, t is equal to 0.4 second. And how about the frequency? Okay, since we have value of t, okay, kita boleh kira lah frequency. Formula dia adalah 1 over t. And it is equal to 1 over 0.4. And the answer is 2.5 Hertz. So, kita kira betul pula. Okay, so the answer is C. B salah lah. The angular frequency, cuba you kira. Omega is equal to 2 pi over T ataupun 2 pi F. So, kalau kita kira, saya tak dapat pun 0.4 per second. Sebaliknya, saya dapat apa? Saya dapat nilainya adalah 15.7. Okay, radian per second. And then the amplitude 10 cm pun salah. So, dia adalah 5 cm. Okay, so finish question 16. So, question 17. So, let's try. Okay, question 17. Okay, so a 4 kg body oscillates in a simple harmonic motion if its kinetic energy K changes with displacement x. Okay, here as shown in the figure, what is its maximum acceleration? So this is the graph of K against X. Okay, always remember, okay, that the value of kinetic energy, okay, kinetic energy would be maximum at X equal to 0. Okay, 0 meter. Boleh? Kinetic energy will be maximum when X is equal to 0 meter. Okay, so kinetic energy, so you can write, you selalu ingat kan, formula kinetic energy equal to half mv squared. Ada yang hafal macam ni. Okay, tapi kena tahulah V ini in terms of X. Okay, V we can write is equal to omega square root A squared minus X squared. That's why, okay, that's why you can write at X equal to A, kalau nilai ini adalah A, okay, you akan dapat V awak adalah kosong. That's why kinetic energy is equal to 0 here. Okay, kinetic energy is equal to 0, okay, at X equal to A. Boleh So kinetic energy dia akan 0. So kinetic energy will be maximum at X is equal to 0. Okay, so formula kinetic energy is equal to half M V tadi kalau kita gantikan omega square root ni saya derive saya just tunjuk saja semula squared. Okay, so ini you boleh cancel out squared, ini akan jadi squared lah, so dia akan sama dengan half M omega squared A squared minus X squared. So this is formula for kinetic energy. Okay, so at X equal to 0, kita baca daripada graph, at X equal to 0, kinetic energy kita is equal to 1 joule. Okay, so soalan tanya apa sebenarnya? Kita tak baca tadi kan? What is its maximum acceleration? So we want to find A. A maximum, formula dia apa? Okay, it is equal to negative A omega squared. Negative showing that the direction. Okay, so dia akan tulis A omega squared. Okay, A maximum, okay, adalah formula lah negative A omega squared. Macam mana you boleh dapat ni formula A omega squared ni? Jom kita tengok sekejap. So datangnya daripada sini. Okay, X is equal to A sin omega T. Okay, equation for displacement. V is equal to differentiate X. Okay, d dt. dx dt you akan dapat A omega cos omega T. Differentiate V, you akan dapat negative A omega squared sin omega T. So, kalau ini adalah V, this is maximum V. So, kalau ini adalah A, so this is value of maximum acceleration. Inilah equation of A maximum. Okay? So, sekarang you nak kira A maximum ni. A maximum, formula dia A omega squared. Ini yang you kena ingat. Okay? So, amplitude dah ada ke belum? Dah ada daripada graph 0.2 tadi. Tetapi you tak ada omega. Okay. So, bila saya tak ada omega, sebab tu saya kena guna maklumat kinetic energy yang soalan bagi. So, now at X equal to 0, kinetic energy is equal to 1. So, saya akan masukkan. Okay. 1 is equal to, saya guna pen hitam. 1 is equal to half. Okay. So, M dia dah bagi 4. Omega squared kita nak cari. A kita dah ada tadi kan? 0.2 squared. Okay, ini awak gantikan dengan 0. Ini akan jadi 0 lah sebab X dia 0. Okay, so daripada sini you can find omega is equal to 3.5355 radian per second. So bila you dah dapat omega, therefore A maximum is equal to amplitude 0.2 times omega 3.5355 squared. Okay, so you akan dapat nilai dia adalah 2.5 meter per second. Okay, so you akan dapat A maximum dia. Boleh Okay, so ataupun kalau you kata you tak nak kira macam ni, you nak terus guna formula daripada kinetic energy. Kinetic energy is equal to half M omega squared A squared minus X squared. So this is formula for kinetic energy in terms of X. Okay. So sekarang kalau you dah tahu A acceleration maximum is equal to A omega squared. Okay. So kalau kita gantikan at X equal to 0 meter, kan ni kosong, kinetic energy awak akan jadi formula dia macam ini. Okay. Di mana, okay, di mana, yang ni tak boleh lah, tak boleh nak simplify. Okay, jangan confuse Ini bukan A maximum. A maximum adalah A omega squared, bukan A squared omega squared. Okay, jadi nak tak nak buatlah satu-satu. You cari dulu omega daripada atas sini tadi. You cari dulu omega. Lepas tu barulah masukkan omega dekat sini. Okay, baru dapat A maximum which is 2.5 and the answer is A. Okay, alright. So finish question 17. So question 18. Okay. So let's try to read the question. So a mass attached to a spring is performing simple harmonic motion with constant amplitude of 5 cm. So saya dapat soalan, saya akan keluarkan dulu maklumat dia. 5 cm which is equal to 0.05 meter. Okay. So the maximum kinetic energy of the mass is given. Kinetic energy maximum is equal to 20 joule. If the potential energy is 10 joule, okay, potential energy, okay, 10 joule, what is the magnitude of the displacement from its equilibrium position? Okay, jadi soalan ni bagi tahu, okay, kinetic energy is maximum masa bila? This one at x equal to 0. Okay, dan sekarang soalan bagi kita maklumat di mana potential energy is equal to 10 joule at x equal to berapa. Kita tak tahu. Dia tak bagi tahu pun U tu maksimum ya. Okay, dia kata U is equal to 10 joule at a displacement of x equal to berapa from equilibrium position. Ini kita nak kira. Okay, jadi sekarang kita nak kira apa dulu? Ini cerita pasal spring kan? So dia spring yang sama. So saya nak kira U, saya nak guna formula half kx squared. Sebab apa? Sebab saya dah ada U, saya nak cari X tetapi saya tak ada nilai K. Okay, the spring constant. So mana saya nak dapat nilai K? Okay, so kita boleh dapat nilai K daripada equation kinetic energy. So jom kita cuba buat kat tepi ni. So kinetic energy is equal to half. Kan tadi saya tuliskan half M, apa tadi? M omega squared A squared minus X squared. Ingat tak? Kan? Tadi kita dah dapat. Dan soalan bagi tahu tadi, kinetic energy dia maksimum. So, bila kinetic energy dia maksimum, okay, automatically X is equal to 0. Okay? So, dia akan jadi half M omega squared A squared. Dan mesti tahu ini adalah K. M omega squared is actually K. So, daripada maklumat kinetic energy maximum, you can find the value of K. Okay, so masukkanlah 20 half, K nak cari, A is 0.05. Squared jangan tertinggal. So, K you dapat 16,000 Newton per meter. Okay, so here we can find U, masukkan K dekat dalam sini. Therefore, kita bukan nak cari U, kita nak cari X. Okay, U is 10, half, K is 16,000, X kita nak cari. So, X you akan dapat 0.0354 meter, which is equal to 3.54 centimeter. Okay, so the answer is D. Okay, so next one, question 19. Okay, so here we have the velocity of a wave represented by this equation. Okay, Y, kita boleh tulis generic equation dia, A sin omega t minus kx. So, ini adalah nilai omega, yang color biru ni, yang color kuning ini adalah nilai K. Okay, lagi satu you tengok. Ini negative. So, means that the direction of the wave is to the right. Okay, ini adalah dia punya amplitude. Okay, so you nak cari apa sekarang? Okay, calculate the velocity of a wave. V is equal to F lambda. Okay, so we need to find first what is F and what is lambda. Okay. So frequency we can find from omega, where omega is equal to 2 pi f. So daripada equation dia yang kat sini tadi, omega adalah 4. Okay, from the equation given, we already know that omega is equal to 4. So we can straightly substitute lah. Nak cari f is equal to omega over 2 pi and it is equal to 4 over 2 pi. Okay, and then lambda lambda kita mesti ingat. Kalau dah biasa buat latihan, you dah ingat. You nak cari lambda daripada nilai K, where K from the equation is equal to 3. Okay, so nak cari lambda, K is equal to 2 pi over lambda. So lambda is equal to 2 pi over K, di mana nilai K daripada equation adalah 3. Okay, so sekarang kita boleh selesaikan where V is equal to F lambda. Therefore, V is equal to 4 over 2 pi times lambda 2 pi over 3. So kita boleh cancel. So kita akan dapat jawapan 4 over 3 cm per second. So the answer is D. Okay, so the answer is D. Alright. So next, question 20. Okay, the last question for this video. Okay, so we have a tube P is closed at one end and open at the other end. So this is the closed pipe. So saya ada satu closed pipe kat sini, P. And then Q is open at both ends. Okay, and they are same length. So saya ada satu lagi kat sini. Okay, ini Q. Di mana soalan kata length untuk P sama dengan length Q. Okay. What is the ratio of the frequencies of the first overtone of tube P? Okay. Ratio of frequency. First overtone. Okay. First overtone untuk closed pipe dengan first overtone untuk open pipe berbeza. So, kena ingat. Kita tulis dulu kat sini. Saya ulang semula. First overtone untuk closed pipe adalah bersamaan dengan third harmonics. Ingat Fundamental mode untuk closed pipe adalah first harmonics. Okay. And first overtone untuk closed pipe is third harmonics. Dia tak ada second harmonics. So third harmonics means that you kena lukis. Saya dah kata untuk closed pipe, okay, fundamental pattern untuk segmen dia adalah bentuk C terbalik macam ni kan. So, bila third harmonics, kita perlu lukis 1, kan, 2, 3. Macam tu bentuk dia. Okay. Tetapi, untuk first overtone, open pipe is equal to second harmonics. Okay. Is equal to second harmonics, iaitu 2 kali X. Okay. First pattern of the segment, fundamental 1, 1X. Dan X yang kedua. Okay. So, soalan nak kita kira ratio. Ratio apa? Ratio of the frequency untuk first overtone. First overtone untuk P tadi adalah third harmonics, iaitu F3. Okay. And for the open pipe, it is second overtone. So, dia adalah F2. And always remember that equation in order to calculate the frequency for closed pipe, Fn is equal to Nv over 4L. Dan ini telah diberi di depan kertas soalan. And for this one, Fn is equal to Nv over 2L. So, kita akan dapat satu lagi. Boleh? Alright. So, now let's try to answer. We want the ratio of frekuensi siapa? First overtone P dulu. So, F3 over, ini yang 3 tadi, ini yang merujuk kepada first overtone untuk P adalah third harmonics. So, dia mesti duduk dekat atas. Bahagi F2. Okay. And it is equal to NV, masukkan equation lah. N is the number of harmonics. Bukan number of overtone. And here is the number of harmonics, which is 3. Okay, this one is equal to 2. So, kita akan masuk NV over 4L. So, 3V over 4L. Bahagi dengan 2V over 2L. Okay, soalan dah kata L dia sama kan? Okay, so kita boleh kira lah. Saya rearrange balik. 3V over 4L darab. So, this one L over V. Okay, so the speed of sound sama, L sama, so the ratio now is equal to 3 over 4 And the answer is D. Okay, so finish question 20. So finish untuk video ini. So see you in the next part, which is part 3. Kita akan discuss soalan 21 sehingga 30. Okay, so see you in the next video. Assalamualaikum dan selamat sejahtera. Bye-bye.